Hi, Mr. Zeimer. Hi, Dr. Vesner. Good morning.
Good morning. Hey, hello.
Hello. Assalamualaikum and a very good afternoon, ladies and gentlemen. Welcome to the second day of webinar on IR 4.0 for water subsector. Please kindly switch off your devices that are close by to the device that you are streaming Zoom from, so as to allow smooth streaming today. We shall begin in about a minute time. We're just waiting for the session to stream through to Facebook and YouTube Live. Hi, Mr. Martins. Hi, Mr. Martins. Good morning.
Hi, good morning. Apologies, I had a laptop crash just now.
I hope it's all right though, after the crash.
Yeah, it's fine, it's fine. It's just when you don't need it to happen, so it's fine. Thank you.
Joe, just checking with you if we are on YouTube and Facebook. Yes, we are. All right. I think we can start now. I just need my colleagues to keep on admitting participants to the Zoom platform. Assalamualaikum and a very good afternoon, ladies and gentlemen. Welcome back to the second day of our webinar, IR 4.0 for water subsectors, the German experience. Without further ado, I would like to invite Yang Berbahagia Datuk Engineer Abdul Kadim Muhammad Din, Chair Task Force IR 4.0, to give his welcoming remarks. Please welcome Datuk.
Thank you, Dr. Nohati, and I would like to wish a warm welcome to all our German distinguished speakers and also any from the Europeans. A very good morning and good afternoon to all Malaysian participants for today, second webinar on the IR 4.0 subsectors. And of course, I would like also to congratulate and also my heartiest gratitude to the German Water Partnership and the our embassy in Germany has been good in coordinating and making this thing happen, because this is part of the study that we are doing on the water sector development for the 4 nation plan until year 2040, and it's about the study on how to transform our water sector in Malaysia. So it's a big plan. It will be a long one. So, and this is a portion of the 8 chapters that we are doing and focusing on IR Water 4.0 for water subsectors, among others. And we would that's why we have identified Germany as one of the good example or model that we should follow our route towards achieving the IR4.0 for the Malaysian water sector. So we hope that everyone enjoys this webinar seminar and gains some experience, and let it not end here, because it's a long journey. So we hope we can get continuous contact with the German counterparts, be whether in Germany, or you have your counterpart in Malaysia itself, and also in Singapore. And today, I think it's going to be very exciting webinar for those topics. We're going to be presented by Dr. Richard Wessner, who is the Senior Director in Bentley Systems, Germany. And we have this Mr. Daniel Martins, also the Regional Sales Virtuosity of the Bentley Company. And also the next is Mr. Christian Zimmer, who is the Manager and Business Development Strategy for Wastewater Siemens. So these are all the big names, and Bentley is not a new name to Malaysian counterpart, because we have used some of your things, but let's focus on Water 4.0, and I'm sure all the speakers will share their expertise and knowledge and experience on this sector that we are building up. Then we can emulate what's good for the Malaysian side. So without further ado, I thank you again very much to all those who attended for this second day webinar, and I thank you again to all the speakers for today's. And I hand over back to Dr. Naiti. Thank you.
Thank you, Yang Berbahagia Engineer Dato' Abdul Kadir Muhammadin, for the kind welcoming remarks, and our heartiest welcome to all of the speakers. Before we start, let me give you as all some housekeeping notes. Virtual or physical meeting, we always have some housekeeping notes, right? So we are afternoon here in Malaysia, and we are so happy to have our colleagues attending from German. They have their morning time over there. Allow me to remind you to kindly please stop your video when you don't need it, or you have some improvement that you need for your Zoom platform. And then secondly, please kindly keep yourself mute. But we most welcome you to shoot your questions during the Q&A session after the first session later today. Be happy to post questions for the speakers in the chat box, and we have also posted a short survey on raw water services in Malaysia in the chat box. I'd like to welcome all of our participants on Facebook and YouTube Live as well. Thank you for joining us in this session. Now, let me take you to the next agenda directly. In today's second session, exploring on the topic Transferring Industry 4.0 Experience into the Water Sector with Infrastructure Digital Twins. We have none other than the much respected prominent figures in the field of infrastructure engineering software, inclusive of over 6 good years in water environment, Dr. Richard Wessner, alongside Mr. Daniel Martins, sales engineer of hydraulics and hydrology solutions at Virtuosity, a Bentley company in Singapore. Dr. Richard is currently serving Bentley Systems as a senior director and has much to share with us on how innovative software can significantly improve and advance our water sector's infrastructure. An ardent contributor to many well-known magazines, such as Smart Water magazine that connects water professionals. He also had been the core team for the publication of article Water 4.0, prestigious white paper published by the German Water Partnership. Mr. Daniel Martins, an enthusiastic civil engineer with a passion for everything water and making our planet more livable, who aspired to connect various disciplines with digital solutions to help improve the built environment. Join me in welcoming both speakers. Let us keep our ears on the ground and hear what our speakers have to say today. Please welcome Dr. Richard Wessner and Mr. Daniel Martins.
So good morning and good afternoon from Munich, Germany. I will start off from our side. Thank you very much for the kind introductions. My colleague Daniel Martins and I am very pleased today to share our experience with you. And, I decided to focus on German Industry 4.0 experience and some analogy to the water industry, because I read your really exciting national agenda for the water sector transformation. Okay, so I will share my screen now and therefore stop my camera to spare a bit of bandwidth. I hope you can see the screen. Daniel, can you?
Yes, it's still in, it's not in presentation mode yet.
Does it work now?
We can still see the regular PowerPoint interface. So maybe if you stop sharing your screen, then I believe, present and then share your screen again.
Does it work now?
Yes.
Yes.
Okay.
Thank you.
Good. Yeah, sure. Well, you know, we especially want to encourage you to start this journey. Do it in steps and use what you have, add and complement, and always learn from best practices. And we'll share what is available today, which kind of proven technology you can rely on. I think it's very important to always identify this journey. Where am I? Where do I start? And I believe we are all aware of digital elements that are and can be applied to the water sector. You know, sensors being increasingly cost effective, contributing to a mass of available data, connectivity of devices and systems and local networks or in the IIoT, now supported by 5G, cloud and edge computing with near unlimited storage and computational power and data analytics, artificial intelligence, augmented and virtual reality, and finally, cyber-physical systems, where digital twins are the base technology. So Daniel and I work for Bentley Systems as introduced, and Bentley is a global infrastructure engineering company providing software, innovative software, to advance the world's infrastructure. Our software solutions are used by professionals and organizations of every size for the whole life cycle, meaning design, construction, operations. And you can see on the right-hand side for what kind of infrastructure I'm talking about, you know, roads, bridges, rail, transit, of course, water, wastewater, public works, utilities, and even systems of systems like cities. And these offerings range from computer-aided design to 4D building information modeling and to the iTwin platform for infrastructure digital twins. And these digital twins reflect and merge asset information and process dynamics. So what is a digital twin? And as the name suggests, first of all, a digital twin is a virtual copy of a physical asset. The infrastructure assets we are talking about can be any kind of object, plant, facility as just seen, or even a system of assets. And to build a digital twin, we collect and merge a wide variety of data from real assets, and some are listed here. So on the left-hand side, we collect engineering data from planning and construction, operational data from sensors or the Internet of Things, and of course, IT data from various information technologies like maintenance and inspection or GIS systems. And we call this the federation of ET, OT, and IT. And with data, you're able to create and curate a digital twin, which in turn drives and enables industry-specific near real-time applications on the right side, usable for better insights, for better decisions, and finally for automation. And these applications can be, for example, mixed reality applications, 4D BIM models, or different forms of analysis and prediction that rely on artificial intelligence, especially machine learning or on physics-based models. Another characteristic of a digital twin is the life cycle approach. That means you have to steadily collect data, keep it updated, share it with all relevant stakeholders, and always pass it on so that you have a life cycle usage of this data. And it consists of context, chronology, and components. So as I mentioned, the highest sophistication of a digital twin is currently being executed in an Industry 4.0 environment, where the digital twin is part of a cyber physical system. There, the digital twin is equipped with forecasting capabilities and gives forward-looking feedback to the physical twin in order to optimize outcomes under steadily changing conditions. In this sense, a continuous data cycle is created, and exactly this is the difference between a digital twin and a digital shadow, right? Which only reflects the physical world without taking any action. So if you want to learn from the Industry 4.0 approach, that started, I guess, more than 10 years ago in Germany's industrial production sector, and adapt these learnings and the appropriate elements to other sectors like water, you should consider the 3 dimensions of a holistic digital twin. That is the asset twin, which covers the product, the facility in its assets, mainly 3-dimensional, adding a timeline to be a 4D representation. It is the process twin, which can cover physics-based models or data-driven models, right? That refers, for example, in the water sector to hydraulics, to treatment processes. Finally, these 2 twins are connected in the performance twin to the company. Think about the ERP system, right? The enterprise resource planning. All of this has to be connected to use the full potential of a digital twin. This complete cover of all the different dimensions should be reflected. Hence, my definition of a digital twin is that it consists of an ensemble of interlinked digital models representing geometry, location, behavior, and performance of a physical object or plant or system over its entire life cycle. Digital twin is in a constant bidirectional exchange with reality in a connected data environment in order to synchronize status, working condition, or position in near real time and to provide forward-looking feedback. And a digital twin enables a better understanding of the performance of the real system and an optimization of its design, production, and operation. Here I refer to the Digital Twin Consortium that we joined as one of the founding members. You can find cross-cutting, cross-industry definitions and terminology state of the art. So this chart, I compare the 4 phases which all caused industrial revolutions with corresponding changes and innovations in the water sector. And even though the steps in water management are rather evolutional, the shifts were not as disruptive at the time. You probably remember and recall this analogy is also in our German water partnership brochure called Water 4.0. So I think if we use the term Water 4.0, the origin should be reflected and considered as a holistic, transformational approach that is now upon us. However, and as usual, there is also a hype, right, around new technologies and new solutions that make bold promises. I'm quite sure that we'll see different digital technologies and business models that sound great and seem attractive, but yet do not prevail in the water sector and disappear after not meeting the expectations. Conversely, emerging digital solutions that solve real customer needs, that focus at the pain points, and have from the start set equally ambitious objectives for the business model as for the technical side, will get through the trough, climb the slope, and develop best practices and growth. Evidence for digital solutions providing value comes from cities where After a phase of base investments in emerging technologies like cloud, mobile, IoT, and biometrics, significantly more money will now flow over the next 3 years in digital twins, 3D printing, data warehouses, mixed reality, and others. However, considering the global water sector, the uneven distribution of water supply and wastewater disposal in different economies, you could ask, is digitalization only an option? Is it only appropriate when you have covered your basic needs? Or in our context, should digital technologies and business models only be considered when you have a full coverage of water supply and wastewater infrastructure and services? Well, not necessarily due to my experience. First, because you can leapfrog technology steps and benefit from learnings of other countries or from neighbor utilities. And that is happening in developing countries, right? And second, the more you understand digitalization as a holistic water sector transformation and include data usage, the earlier you can support your water sector development and transformation and accompany with relevant initiatives that match with your actual sector maturity and help to make this transition sustainable. And I think in this way, both demands will be satisfied: deficiency needs and growth needs. There are studies, recent studies available to better understand the degree to which water infrastructure owner operators are able to leverage new technologies. And as you are specifically interested in German experiences, I want to refer to a scientific report assessing and creating a digitalization index for the German water sector. This report is very much aligned with the German Industry 4.0 approach, and hence you can see here 6 corresponding maturity degrees were defined and evaluated from utilities across Germany. Aligned with the Industry 4.0 definition, Water 3.0 ends with using computers and being connected on the bottom left. These are the first 2 foundational steps. And Water 4.0 starts with step 3 and covers capabilities regarding visibility, insights, forecasting, and autonomous adaptation. Assessing 4 key areas of interest, namely resources, IT systems, organization, and culture, mentioned here, the results for Germany as a mean values over all respondents clearly show that the German water sector and companies have reached the first Water 4.0 maturity level, but there is still work ahead if higher steps shall be reached. There are a couple of conclusions and recommendations in this report which point at requirements like software interoperability and integration and the seamless flow of data by appropriate interfaces. And why is that so important? Because the water utilities face a 3-fold data challenge today: the volume of structured and unstructured data, the variety of sources, formats, and vendors, and the velocity of change. So to meet operational and strategic targets, water utilities have to build on a connected data environment that provides a single view of truth. And this is the foundation for using and merging data from different sources and systems and build reliable digital representations of networks and of plants that are in sync with their physical counterparts. Applying this digital twin approach helps creating end-to-end water solutions that cover the entire water cycle and involve all actors and all stakeholders. So, knowing that the water sector has already invested in digitalization, this process can be done in steps that take into account what already exists. As I said, there are many ways to implement and federate digital tools and systems, and that's why you don't have to change the way you're working today. Many utilities have invested in sophisticated GIS platforms. Others are working with CAD or BIM and use hydraulic network modeling, for example. Some of these elements are mentioned on this slide, and I would like to demonstrate how some of these or all of these elements can be unified and merged to form a digital journey, how we put them together. For that, I would like to start with 3D reality modeling, which is a good and fast entry point to digitize your assets and advance your visualization capabilities. The data here comes from merging camera pictures and laser scan point clouds. Often your smartphone is just good enough to capture this. You can do all kinds of measurements, including calculations of volumes and sizes. You can deploy virtual reality in the field and make planned or built asset information visible. The clip here shows the location of various underground lines, which can be used to localize hidden points of interest, right? To execute collision checks during planning. Next to the location, you can even reflect the pipes true in scale with 3D with elevation and diameter. And you can display actual asset data into the lens, such as material or age or flow and pressure. If we turn to a plant asset, like a pumping station, this example shows to which extent we can capture reality data from overlaying digital surveying and photographs to create a 3D asset twin. What you see here is a full-scale test facility at the Technical University of Berlin, which is actually a demonstration project of German Water Partnership supported by Siemens, Bentley, and other members. Once you have a 3D reality model like the one before or this one, you can bring it to life. Today, automatic image recognition is able to detect devices and services and connect it to PID and SCADA data. And this is where I would like to bring in my colleague Daniel to the stage, who will showcase a little bit plant and network related examples. I'll stop sharing for that.
Sure. All right, thank you. I'll do the same. I'll stop my video. So what I'll present is just a few videos which show some examples of a plant and basically network digital twin. Since these can be bandwidth heavy, I'll just stop my video and start sharing my screen now. Kindly do let me know once you can see my screen. Which I'm sharing now. Okay. So yeah, what I will show here serves as a brief introduction to our digital twin solution for plants first and the networks as well. So just pausing here, not playing the video at hand. What you see here is a browser-based interface which allows you to easily visualize and navigate your plant on a desktop or mobile device. So you have a menu on the left. It's very intuitive. And when I'll start the video, we'll start searching for a specific element, a pump in this case, because what you see here is an array of data, right, which comprises reality information as well as 3D models. But obviously from this point of view, from this perspective, you can't see much, right? So once we start looking for a specific element, the digital twin allows us to easily allocate that element, right? So it went a little bit fast, but now we've zoomed in to that specific pump. You can see it's identified here with all the corresponding information of that pump. And you can see how it's represented with the surrounding array of assets. To take a closer look, right, to really see how that, how it shows, how it displays in the complex array of assets that's surrounding it, we can, delve deeper, see it in 3D, navigate it as we wish. Now, should you not have such a 3D model, right, which not everyone has, there's obviously reality modeling data as information, as Richard already mentioned. So you can obtain a realistic 3D reality mesh, as we call it, from imagery or satellite data. right? So you can use drones, you can use mobile devices to capture images and stitch these together to create what we call a reality mesh. So what we see here is just that. This is a reality mesh, and we have now identified a specific element, a specific asset, a subset of our overall system. The beauty of this digital twin is that we have this so-called PID Intelligence Viewer, which uses machine learning algorithms to easily link and tag and allocate specific elements from your reality model, right, to your PID drawings, so that you can identify a certain element, right? You can tag it here, and then you can leave tags, and the machine learning algorithm will then easily it will save it in your model, and anyone who accesses this model, right, or this platform, whether you are in the field or a decision maker, can easily see and navigate their way through either the PID drawing or the reality model. Moreover, you also have the ability to view the performance. So if I just pause here, because it's a little bit fast. The performance and operational status of any element within your plant, as well as your plant as a whole. So whatever information you have, operational information, you can drag that, you can load that into your digital twin. You can tag it, you can leave comments if you wish, right, for enhanced collaboration. And that enhanced collaboration, as we see here, really allows us to have a quick overview of what's going on, what's happening in our plant, in our asset, who has done a certain quality check, a performance check, and are there any issues that need further attention. We can delve deeper into those specific issues and really see where in our digital twin, where in our 3D model in our asset, those issues have arisen. So that's one perspective. That's from the plant perspective. Next, what we can also do, we can go to the networks, right? So this is just an overview of a dashboard. On this dashboard, you're basically welcomed by a bunch of information which can be customized, right, to your needs or to a user's needs, and see a variety of information on the status of the network, of your sensors in your network, if you have any sensors that are loading information into your digital twin, your pumps, tanks, your water balance, your water audit, and so forth. So if we have a look here, what we see here is basically a map with an overview of all these sensors in our network. And if we select a particular sensor, you can see the corresponding information that represents the information that comes from that particular sensor. You can delve deeper, you can compare all the different sensors, you can see them side by side and see how the accurate data compares with forecasts. And as such, you can navigate your way and you can find outliers within your data or within your system. You can also do that on a zonal basis. So you can identify specific zones and then for each zone, see such data as well. Now, jumping ahead a bit. So what we're seeing here is just some information on pumps. Should you have such information in your, built in or loaded into your digital twin, you can compare pump performance with the best operating point as indicated here. You can assess for various pumps and tanks and compare their status at any time, whether it's in a graphical manner or across a time series, as whatever gives you the most information or wherever you derive the most information from. Now, another interesting point is obviously the water balance. And here we have basically an overview of a sample water balance, meeting AWWA and, oh, apologies for that, and IWA standards. And the digital twin automatically calculates this water balance based on your billing data. And you can view this in a variety of formats. You can compare different water balance components for different zones, right, in terms of percentage on the bottom and volume on the top. And you can also actually compare it in terms of cost. Obviously, if you want to see, so I pause it for a second, if you want to see how the cost in terms of, or how the comparison is made in terms of costs versus percentage and versus the volume that we just saw. So you can easily compare different zones in your network and even display that on along a time series and extract that information to see what is going on, what the current status is of your system, what your real losses are, apparent losses, and non-revenue water that may be present. Now, lastly, this is the last part of this, just to highlight. So what we just saw was basically information that comes from your SCADA systems, right? So that's from your pumps, your tanks, your sensors, and just now we saw the water balance. What if we combine that with a hydraulic model? If we have such a model present, we can do so, and we can. This allows us to easily see and carry out certain scenarios, let's say emergency response scenarios, as we'll see here. So what we see here is basically a map which you can easily navigate through. You can see only the SCADA data. You can color code it as you wish, but you can also see the network information, your hydraulic model information, identify or select any specific element, and then see the status or water level, let's say flow or pressure at any point in your system. Furthermore, you can carry out emergency response scenarios. Let's say you're an operator, or you're just, you don't have time to delve into the complex array of hydraulic models that are in the background, but you just quickly want to do an assessment on a potential pipe break scenario in this case, right? So you can easily select a specific element here and run a pipe break simulation. And what it will do, it will immediately identify the customers that are affected and whatever information you have stored in your digital twin on those customers. So be it phone numbers, email addresses, of course, geographical addresses, that can all pop up, can be shown and shared, extracted then, so that you or your field, your people in the field can contact those people and inform them of any, let's say, downtime. And you can also carry out some decision-making scenarios, make some decisions based on what a best solution may be moving forward, right? To which valve should be closed and so forth. Now, it was very, very brief, but I hope that gave you a quick overview of what basically a plant and network digital twin can look like. We can obviously, show you much more, and we're always available. I'm based in Singapore, by the way, to do a more in-depth demo. But I believe at this stage, I'll just pass it back to Richard so he can continue with his part of the presentation.
Thank you, Daniel. So,
I just
we have to stop sharing first, right?
Yes, indeed.
Okay.
It's
so
still
is
in
that again?
Yeah, you have to do it in presentation mode first and then share, I believe.
Fine.
Not yet. If you reshare your screen, then it will work.
Okay.
Yes.
Daniel, thank you. So with ingredients we demonstrated up to now, I think it is also important to identify water network, a plant, or the water sector in general as part of a bigger system, right? And I'm talking like a citywide or utility-wide information platform. So what I'm showing here is data about construction projects in an early phase, which can be shared with citizens or with stakeholders, right? With all kinds of politicians. Oh, okay. So sorry for this. Just crashed, right?
It seems like it. Yeah.
While I'm fixing this, do you want to pull up the first question and I just try to relaunch here? Sorry for this.
Yeah, actually, what I also want to highlight is because we have quite some video material, as you see. Obviously, all this, whatever we show, is can be shared. So no fret. If any of you had any lag in the videos just now, not to worry. You can always contact us and we can share the materials or do another session.
Right. It looks fine, Mr. Martins, on YouTube and also on Facebook. The video seems smooth. But we do have a question here from Mr. Alain Duquesne. For, say, a small wastewater treatment plant, what would be the cost and time required to generate a functional digital twin? For example, starting from scratch with PNIDs and as-built-in plans. And as-built plans.
Richard, shall I take that, or are you?
Please, I'm still fixing my issue.
Okay, are you still
here.
fixing? Well, Alain, thank you for the question. It's, I presume you know the answer to that. It's first of all, it's difficult to say without having further information on the plant exactly, but you can always contact us and we can have a further discussion on that if you wish. So then we can basically what we need, obviously, we need to understand exactly the extent of work that is required before we can give an estimate, because it varies quite a lot.
How about time? Yeah. How about time frame required?
It's almost the same answer. So what we've seen across the board, obviously, whether it's it really depends also on first of all the maturity. So what data do you have available? What's the current state? How much effort is required? The basic questions, which sound a bit cliche, I understand, but I would say contact us and we can have a further discussion on that to have a better look at that. Yeah.
Am I back here, Daniel?
Yes, you are.
Yes, you are.
Okay, so I'll show one or two other examples and then summarize what we have spoken about, and then we can go again into details. So what I was saying, share data about your utility operations and construction plans, like you can see here. Right? Imagine this object being a stormwater retention basin or another water infrastructure asset instead of a subway station. From an engineering perspective, digitalization allows to integrate CAD or BIM models and create an immersive impression connecting to all relevant design data from one portal. And all of this can be shared according to the administration rights with the public, right, at an early stage. Of course, all of these digital twins can be visualized for wide screens, for example, for a central control room, or opposite scale for handheld devices used by field technicians. So the last thing that I want to mention and show here is how you can use mixed reality for O&M requests, right? You can handle them predictively and without being an expert in that particular domain by using these lenses. The work order is projected into the lens and concrete hand moves are displayed. And of course, this can also be a relevant contributor to education and to training of utility staff. So now to summarize what we have been speaking about, I mean, yes, indeed, there is a lot that cannot be digitized or digitally transformed in the water sector. Water itself is a vital physical resource and we'll still have to extract, collect, transport, treat and protect water with physical infrastructure. But pressure on water infrastructure owner-operators is growing in terms of total expenditure, customer expectations, and the war for talents and knowledge. So further, governments, shareholders, investors, but public societies are increasingly requesting to meet demanding sustainability goals according to the UN's Sustainable Development Goals. And here is where digitalization as a cross-sectional approach offers to manage and connect core challenges and serves as a foundation for innovation and collaboration. Well-prepared water sector actors are now embracing digitalization, such as by creating digital twins of water systems. While this may have been quite fast, all our examples here, I hope you got an idea of this endless possibilities we have with today's technology. What I would like to reiterate is that digitalization is not only for the big and skilled organizations. I was showing in Daniel interconnected digital technology off the shelf, ready to apply today, right? My application examples were tech heavy, but as I stressed before, if digitalization is interpreted and executed as a sustainable, holistic, and fair water sector transformation, then smart water services from public and private companies will come with digital capabilities that are interacting and intertwined with a sector and business strategy, with a digital corporate culture, and with an agile learning organization that is committed to and poised for change, where capabilities refers to connectivity through an appropriate IT architecture, creating a connected data environment, refers to data-driven decision-making with digital twins developed towards automation of water systems, and it's referring to customer experience through visualization and collaboration technologies that are available today. So I think digitalization will not stop at the water sector. It's already there. It is up to us to see digitalization as a chance and to shape and use this approach in a positive way. So I hope that gave you a little bit of an overview. Daniel and I, of course, very pleased to support this session today. And we have some time left for your questions. So sorry for the breakdown of my computer, that happens sometimes. I hope you still enjoyed what we showed to you. And of course, we are now open for any further questions or for connecting with you afterwards. Thank you very much.
Thank you, Dr. Richard and Dr. Richard Wessner and Mr. Daniel Martins for a very nice presentation. And I really like the video presentation because it gives a much more clarified overview on what is it that you meant by the twin systems. We have another comment, so a side question from Alain Duquesne. The digitalization using mobile phones, this require the new LiDAR feature on the newest iPhones and iPads, or does a normal camera with a suitable app work? If the latter,
both.
Work.
We use whatever you have. You know, the good thing here is you can do it stepwise and the technology can advance. So of course, better technology provides better data, you know, with bandwidth or with details and with accuracy, but just start with those elements that you have available today. And the good thing is there is a phone, right, that has this LiDAR inbuilt today. You just have to download an app and then use it. But you also have specific devices. So I say add these different elements stepwise and just build a journey out of this. And remember this one slide with all the different elements there. Just put it together, but you should have a strategy behind so that you're really focusing to the target. And all of these steps should have a return of investment. That makes the digital transformation really valuable at any of these different maturity steps. I hope that answered your question.
Thank you,
Okay.
Dr. Vesna. And then,
sorry, I have a question, Dr. Nati, for Dr. Richard and Daniel.
Yes, Dato, please.
Okay. Thank you for the good presentation. Very exciting, very interesting. But whilst we are too excited on all those what they call ICT or IoT, can you share a bit on how you look at the security part? In this world we have a lot of hackers, and we are too dependent on all this automation. If we've been hacked, will there be a disaster? Is there any contingency plan? And how you store your data? Because we talk about a lot of data here, big data. And one of the things that we have in Malaysia talk about is Personal Data Protection Act that we have, and this include all this customer that will be included in the data. So in short, how does the Bentley system look into the security of this automation in the system?
So many answers to this. I try to keep it short. First of all, we support different kinds of. No, let me rephrase that. I think cybersecurity is a very important. It's a requirement, right? We have to have secure water digital twins, and that means you have to take measures from an owner, infrastructure, or an operator perspective. We, with our solutions, fit into your security system, right? We are not security experts, but our applications, our platform, use, of course, the highest technology, the most secure technology to support our applications, but within your framework, right? If you see very recent threats, then you read and you understand that this was not actually because an application was not sure, but more because some human didn't respect cyber security regulations, right? Just plugging in a stick or leaving a door open to talk in an image. So I think what we have discovered in what you can read in different reports today is that an important element of your transformation is grow the skills of utility staff or of responsible staff members. Without growing and advancing skills within digital technologies, you will have issues like this. So everything has to grow stepwise, not only technology. As I said at the end, technology is one part of a digital transformation. You also need the structure, the organization, the skill of your people. All of this has to grow stepwise. If one of these is far ahead and the other domains, the other dimensions of this transformation are lagging behind, then I see there is a risk, especially for cyber attacks. So, we can provide applications that run on premise. We, of course, support today cloud solutions. We are using actually ourselves the highest protection shield by cyber by networks, right? By cloud platforms which are available. And we trust that these offerings, these services do much better in cybersecurity than our company can. So we ourselves, we are using this and offering this then to our users too. So it can be deployed on a premise, it can be deployed on a private cloud environment, but you will really embrace the full computational power if you go to a native cloud environment, which today has a lot about and has to secure a safe environment. So we trust that these companies, these hyperscalers, know what they're doing. And if you really dig into cyber physical attacks these days, you will find it's not because a hyperscaler has not, closed the door somewhere, is not safe. It does not provide a safe environment. It's more that we had actually human action which are misaligned with cyber physical regulations.
Thank you, Dr. Vesner. We have another two questions here in the chat box. One is from Mr. Muhammad Khairi, Academy Science Malaysia. How did Bentley develop the robust and complex system? What are the preparations and plannings that Bentley do to develop this system? Probably briefly.
I don't really get the question, sorry. How do we develop a robust system? Was that the question?
Yes, the question here says that the system that you presented seems to be robust and complex. So what were the preparations that you made and what were the plannings that Bentley did to develop?
Okay, yeah. Well, to be very clear, these more sophisticated solutions that you showed, especially Daniel showed, right? These operational digital twins, they are not plug and play yet, right? Not everything you just download an application, then it runs like this. So you need preparatory steps. And then we work together with so-called digital integrators. We have a digital ecosystem, and this together provides kind of the full-fledged solution to the end user, like a water company, like a water utility. So, of course, this very much starts with identifying where is the end user at what maturity level, right? Remember these different steps in the German Digitalization Index. Are you using computers? Do you have a hydraulic model? Are you already going into visualization? How far is your automation process? So identify where you are. Secondly, together with the company, with the user, define where do you want to be when. So really pull out a strategy. That strategy is really an important part because, as I said, you have to combine and do in parallel different steps, right? With the workforce, with your organization, of course, with your users and customers, and with technology. So the strategy has to be there. And of course, finally, the data quality is very important. So probably if you look at your data, you will see that it's not really clean. You have to clean that up. You have to sort it out. You have to really look into this. Where is it coming from? At what frequency do I really need this information? Sometimes you need a different sensor. Sometimes you have too many sensors. So there would be preparatory work required. And this is something that digital integrators do, right? Your advisor, your local consultant can work together with us on this. So we bring these digital integrators up to speed, get them familiar, make them familiar with our technology, and then they act kind as of a bridge, right, between the technology implementation on the one side and the digital implementation on the other side. I hope that was the answer that you were looking for.
Okay, thank you, Mr. Vesner. Mr. Muhammad Khairi, we hope that answers your question. And we have another one here from Dato' Abdullah Isnin. What would be the best approach to tackle data integration challenges? Appreciate if you can share your experience dealing with cloud silos to accomplish a digital twin or system transformation?
You know, everybody today is looking for the one and only solution and answer, right? And that's probably not really what I can offer. As I said, and Daniel also mentioned that, it very much depends where you are and what you have and what you want to do, right? What kind of system do you want to rely on? You know, you have invested probably heavily in the past years. So I would state the water sector doesn't start from scratch. We always find something available. And my statement was all of this has value. So to make this inventory, right? And I agree, and I had this slide showing all these different silos. But what you need to do first then, when identifying what you want to keep, is how to connect this, right? And then you have to build this connected data environment. And we offer this platform where we, according to your target, right? Is it more network oriented? Is it more plant oriented? Use our applications and the power of the cloud in that case, because that was the question, to identify the right pieces of this full picture. And that's why we at the end aim for and provide a single view of the truth, right? A single view means we just identify what is required to achieve your target. And then we pull in this data, we federate this data in a highly automated approach. And this is what our so-called iTwin platform does. So technology is available doing that. It pulls in the right information from the right sources, brings it together, and then provides this merged and federated IT, OT, and ET information. Some of this, and we can demonstrate this more in detail in a separate session, some of this needs a timeline. So if you think about engineering technology, the advancement from 3D to 4D requires a synchronization and requires a time step. And all of this is done in what we call an iModel hub, where we actually add a timeline to three-dimensional ET engineering technology data. And if everything has a timeline, then it is federated and then builds a digital twin, and that provides power to different devices. So, there is not, one approach. There's not, one way to do this. You have to see what you have, what you want to keep, what you have to amend and to add, and putting this all together. Technology for this is available. It's there. You can just subscribe, right? But you have to really identify this according to your needs and according to your strategy. So I really recommend to start with an inventory aligned with a digital strategy.
Thank you, Dr. Vesner. And I think before we move to the next speaker, I'd like to take this last question from Elaine. What, in your experience, have been the most important results or benefits of having a digital twin of a water asset?
Yeah, really good question. Can I take a step back? I would say, what is the first advantage of digitalization in general? And as you saw from these different steps, I always say, the first low-hanging fruit is visualization. We are all really intrigued and kind of led by what we see, right? So once you see a 3D environment of your asset, where you can add analytics, where you can add this power of looking into the future, comparing with the past. If you see this in an environment, if you embed your wastewater treatment plant, right, in the environment of your network, if you see how all of this works together, visualization really helps you to understand what you have to do, where you have to invest, what you probably have to stop, where you have to advance, right? So visualization is always the first and low-hanging fruit. That's why we talk about this digital context and components, which is really to create as real as possible the environment of your digital twin. And then probably the next thing is really these insights. So understanding how this all works together, influences each other, use the power of analytics to create new correlations that have been dark, right? So this data is hidden somewhere. Now you bring it to life, you bring it in context, you compare it, and then you have new insights. And further down the chain, but these are the other maturity steps. Of course, you can create this real 4.0 implementation steps where you have self-learning, reconfiguring systems that you kind of automate your system, right? Think of this closed loop that is probably at the end of your maturity steps. But this is, of course, already today working in digital factories, for example, in the car industry. And Christian Ziemer from Siemens has a lot of experience and can show examples where Industry 4.0 is real, right? It's not yet there in the water sector, but we are moving towards this. And I encourage you to take all these small steps toward this goal if it is appropriate for your organization.
Thank you, Dr. Wessner and Mr. Martins, for very nice presentation and experience sharing. And today I'm so glad to have questions also from the participants for both of you. We thank you so much. And ladies and gentlemen, let us now move on to our next speaker for today. We have an exciting topic on the lesson learned and way forward, meeting the challenges of water management with standardization and digitization. And here we have Mr. Christian Ziemer, Manager Business Development and Strategy, Water and Wastewater at Siemens, who is responsible for global business development and strategy for the vertical water and wastewater organization. He brings along his over 20 years of invaluable experiences with Siemens Digital Industries, an innovation and technology leader in industrial automation and digitalization, and has been the driving force for the digital transformation in the discrete and process industries. Mr. Ziemer has led the international sales and business development with solutions for various water processes covering North America as well as Asia Pacific region. He also volunteered himself as the head of Working Group Committee Water 4.0, the white paper published by German Water Partnership that focuses on digitalization and automation as the core points of a strategy for a water management which is at the same time resource efficient, flexible, and competitive. Ladies and gentlemen, without further ado, let us welcome Mr. Christian Ziemer. The floor is yours.
Cool. Thank you very much for your introduction. So you see there's a lot of experience. So I started Siemens in '87 yes, welcome. And I'm quite happy to bring our insights, what has been developed so far, what are the next steps. And I can agree with Richard because Richard and myself, we are empowered people in the water business. We are driving this water initiative, this digitalization forward, and it's a journey. And I'm quite happy that you have started this journey because it takes a while to have the same understanding what we're talking about. And I'm quite happy that I will follow up also on Richard's agenda because I think we have lessons learned. And I would like to start my presentation, including also some videos about our references we have done with the automation and also the next steps together with our partner, strategic partner, Bentley Systems. I think this collaboration fits perfectly in the next steps on Water 4.0. But it's a starting phase. We have to start now and to move forward to the next steps. So now I will also skip my video and to share my screen. So I think it will be this one. So do you see my presentation?
Not yet, Mr. Zemer.
Okay, maybe I have to do this one or to share my screen.
Yes, it's coming. Okay, if you can put it on.
On the presentation mode.
Yes, please.
So I will try it to make it on the presentation mode. So I think I have to change the mode. So
yes.
Cool, perfect. So I have also a small agenda, but I would like to start with the holistic view, because the holistic view, I think it's the most important view, that water is the heart of a sustainable development. And it's really critical for the economic development and also for the environmental sustainability and the human well-being. I think this is mandatory, and this is also the lessons learned and the way forward. And the IWA is inspiring us to have more focus really on water and our development together with this challenge. And what I'm saying is the way forward will be to have a standardized solution. You have to standardize your activities, and then this will be the next step to go on the digitalization. So my agenda today is a short presentation about Siemens and the topic. I would like to highlight the water cycle. What does water mean? Yeah. And then to come back to the water as a global challenge. It's not only a local challenge, it's a global challenge. And then I would like to come to the Germany, the industry picture of the German water industry. What are the highlights? What are the lowlights? What are the way forward? And as Richard mentioned, he showed this maturity check from Professor Oehlmann. And I had a meeting with Professor Oehlmann on Monday, and it was really good to see the interviews of roughly 200 utilities in Germany, and to see at which stage they are. And as Richard mentioned, we see this maturity level of roughly 2.9 or 3. So there's a long way to go also in the German water industry, but we have started. And I think together with the utilities, with the consultant, with the EPCs, we are learning together with the utility companies. And this is also important, that we have to be open to discuss what are the next steps, what are the KPIs, what are the benefits, what are the direct benefits, like save money, what are the indirect benefits, what is the benefit of a digital twin. So it's also a learning curve here, but we have started this journey. And I think the next step is really, as Richard also mentioned, the picture to have a water 4.0 picture about standardization, digitalization, and sustainability. You have to think in sustainability, otherwise you are lost. And what will be the future? And I think the future will be take care about our resource, water. Okay, so Siemens, I think Siemens is well known globally, but I think I'm also proud to work for this company, because it shows 173 years of social responsibility. And I'm so proud because also my colleague, Johnson Tan, is joining us. He is my counterpart in the region in Malaysia. He's located there. And this interfacing, so we are thinking the same, we have the same understanding what we would like to go. As I mentioned, and also as Richard had shown, we are talking about this Industry 4.0 approach. So let's say the laser pointer, this 4.0 approach. So we have adapted, and Richard and myself, we have adapted this 4.0 approach towards the water 4.0 approach, which means digitalization. And as Richard mentioned, also this kind of cyber physical systems. Maybe this is at the moment a future vision, but we are moving into this direction. So a little bit about the Siemens organization. So we have our Siemens Healthineers. We have a split off of Siemens Energy. And now we are talking about Siemens digital transformation of industry, infrastructure, and mobility. This is our DNA. And also, as Richard mentioned, infrastructure, digitalization, we are combining our strength to have a sustainable use of our resources. And one of resources is water. And I think this is mandatory to think about it. And we are providing technologies to that. Yeah, I think technology is available, is key, but it's not the only one. So what I'm saying is, and this is also the overall strategic priorities, we have to talk with our customer. We have to talk, we have to enable our customers and to have really a discussion with you about the next steps. We have empowered people. I think this is mandatory in every organization, that we have to empower our people to tell this story, what I'm telling about. Technology with purpose. So it's not mandatory to have technology available. You have to put the right steps to integrate technology into innovative solutions, to integrate technologies to come to the next steps of a digital twin. And I think it's also important to be open, yeah, to have the growth in the mindset, yeah, being open to change. And I think this discussion today shows that you have an open mindset. You're talking about looking into other regions like Germany, Europe, or United States to see best practice examples. And we are providing best practice examples. Okay, this is a short overview about the organization. We are talking about digital industries. And also our core messages, 21 is digitalization and automation is important. Point 2 is we have a very strong position with our partners. We have the digital portfolio available. We have the right solutions for different sectors. And point 3 is we are integrating more intelligence into our products and design of the production. As we have already heard about edge computing. Okay, we are integrating all this cloud computing, integrating in our products, in our controllers. Then it's getting more easy to have the I/O integration into the cloud when you're starting with instrumentation, with a flow instrumentation. If you have this information already available in the cloud, I think this is mandatory to start also with the product design. And as I already mentioned, we have to be close with our customers and we have to support throughout the whole processes. And also the answer, what are the next steps of how we can start to make a digital twin of a wastewater treatment plant? It's always a question of data quality. And we had a discussion with the biggest utility here in Germany. And when I see the data quality of existing plants, so they do not have an intelligent PID, they do not have 2D, 3D models, so they have paperwork, so they have PDFs. So we have to integrate all this kind of information into this digital twin, and it takes time. And as Daniel also mentioned, we have to sit together, we have to analyze your data, and then we can say, what should be the next steps? What is your goal? Yeah. And for this reason, we have to think in ecosystems. And what I'm saying also, we have to think in partnerships, because Siemens is a huge company, but we have seen also that other companies like Bentley or Microsoft or Google, they have also nice features. And for this reason, we need strong partnerships, not only developers, but we have to think in partnerships as well. And I'm also proud of our strategic collaboration with Bentley Systems, because together we are stronger. And together we have developed this plant site digital twin cloud services, because we have learned that we have experience in different discrete process industries, and to combine our strength with the strength of Bentley, I think this will bring a digital strategy towards our customers, and this will give you a competitive advantage, or in the respect in the pharma and the pharmaceutical industry, will also growth and bring profitability to you and both companies. So, and also to mention that we are talking also with the Microsoft or Amazon Web Services. These are really secure platforms where we can rely on, because security of Amazon Web Services, the security of Microsoft, I think this is their DNA. If they fail, a lot of people will fail. And for this reason, to build an ecosystem on strong partnerships will help to get the next level of digitalization. We are talking about process industries. We are talking about discrete industries. We will bring all this nice information together and to bring the focus of the different process industries into the DNA of our industries. And I'm talking about water, wastewater. I'm responsible, as already mentioned, in Siemens, in the digital industry, process automation. I'm also driving this Water 4.0 initiative in the German Water Partnership Organization, and together with other partners in the German Water Partnership, we developed this Water 4.0 nice brochure where we sit together to define what are the next steps. We are talking about cyber-physical systems, but I'm also part of the German Water Association, European Water Association, and also in the industry like the chemical, pharmaceutical industry, because we are not only talking about water in the municipalities, we are also talking about water in the industry. And as I mentioned, water in the industry is one of the most key elements to bring nice products. Furthermore, we are also part of the Smart Water Network Association, where we combine different views from different companies to have a common overview about the next steps towards Water 4.0. So, what does water mean? So, water in our view is, what are the key challenges? And the Global Water Intelligence says quite clearly, cybersecurity is one of the key. Efficiency and cost is another driver, and also security of supply. Climate impacts are changing our world. Aging workforce is driving digitalization forward. This digital transformation is also the reason why we are talking to each other today. And what we also see is the regulation will change, the regulations getting stronger and stronger. And we have to think about the water cycle, from desalination towards water distribution, towards distribution in the cities, and also the cycle of wastewater treatment, including the industries, what I'm talking about. And these are the lessons learned. We have to have an overview, we have to create a picture, we have to create an ecosystem with standardization and digitization. And I think it's also quite important that we have to raise the question where we stand now. And we have the water crisis, and the World Water Day shows clearly that water and the climate change will change our way in living. So, as I mentioned, the water crisis is happening now. The climate change will affect the availability, the quality, and the quantity of water, and threatens the effective exercise of human rights on water and sanitation. And this will be for billions of people. Also, the hydrological changes caused by climate change will make it more difficult to manage all the water resources that are already under severe pressure in many regions of the world. And again, water is connected to the food security, human health, urban and rural development, energy production, industrial development, and economic growth, and ecosystems are all dependent on water and are therefore vulnerable of the effects of the climate change. I think this is, we have to have this picture in mind, that water is really important for our development and human health. I will show a small nice video. Hopefully it works, because last time I had some problems with that. Yes, I think we have summarized in this nice movie all the challenges we are facing, and also the combination of electrification, automation, digitalization. I think this is the way forward for a secure water supply. So coming to the next point, the water in Germany, and the organization of the different association. They have combined their views on the profile of the German water sector. And you see, there are a lot of associations working in the water sector, but they are also in a close collaboration with the cities and the towns and the municipalities. And what I'm saying is, we have to talk with the politics, we have to talk with the associations. They will bring up the regulations. And I think it's quite important to have the overall view about a water sector in your country. What is the water sector in Germany and what is the water sector in United States? It's completely different. So in Germany, we have roughly 6,500 utilities on the water side. And we have also 6,400 wastewater treatment utilities on the wastewater side. So, and you see the diversity, yeah, and the main goal is also to combine the situation of the different utilities and to bring them into the next level of digitalization. So, as a summary, in Germany, I think we have really a strong organization and the economic efficiency. In Germany, water supply and wastewater disposal are core public services in the general interest, providing within the competence of the municipalities or other public law corporations. The democratically legitimization bodies make the strategic decisions regarding form of organization, shareholdings, and working collaborations. Charges, quality, environmental requirements, water abstraction rights, and discharge rights are subject to strict governmental control. What does this mean? This means that the governmental roles have to be defined and has to support all the utilities. This regulation, I think this is a strength of our German water organization, this organization and economic efficiency. A second strong point is that I think we have a strong performance because we have first-class technical standards, and these are in compliance with the strict legal requirements. So this means that, for example, the German Water Association is dealing with the European law, and this is necessary in order to have really a high performance in the drinking water supply and wastewater disposal. And there are also tasks and challenges. I think we started also in Germany this transformation, and we have learned that also this maturity check, we are seeing that the maturity check is on the level number 3. And we have big challenges as well. We have the problems of detection of anthropology trace. And we have also the problem of aging infrastructure. We have the demographic change. And this is driving also this digitalization forward, these tasks and challenges. And as Richard mentioned, we are on the level of discussing with the utilities about the next steps we can go forward. And here's also the link on the Branchenbild in the English version, because I think this is also mandatory to learn from other countries and to set up also an environment in your country. Okay, let's start also a movie how we do it in the waterworks. So how is that forward?
Mr. Zeimer, the video has no sound, no?
This is the problem, that the video has no sound. I have the sound here, but it's not transferred to the video.
No problem.
But I can send the link. It's on a YouTube platform. You can see it. What I'm saying here is, this is that the standardization of the waterworks in North Rhine-Westphalia. So they started their journey 10 years ago with the standardization of their controls. So they decided to standardize on standardized function blocks on the automation. And what we see here is this collaboration between company Wasserwerke Westfalen and our sales manager, Mr. Frenzel, saying, okay, what are the ways to go forward with standardized templates, how we can standardize the different waterworks, how we can standardize the different wells and so on and so forth. And this is the combination of the central control room, where we combine all the different wastewater water treatment plants and also wells into one common platform. And this ensures a smooth operation of all the dams, of all the waterworks. And let's say this was also the lessons learned, that standardization, as I mentioned, is key also for the training of people and also to move forward. But it should be always open. Yeah, open standards are necessary to integrate different system integrators into those different waterworks. Yeah, for example, if you have 10 waterworks with different SCADA systems, so it's really difficult to have a training session on the different SCADA systems. For this reason, they decided to build on a standardized DCS. This is a SCADA system, and for this reason, standardization was key for them to have the next steps on digitalization. So coming to the next point, Water 4.0, standardization, digitization, and sustainability. Water 4.0, I think this is really the next step. And I think every utility, they have to start, what are my challenges? So what I have seen here in Europe and also in abroad, if you have the question, how do we simplify working on a water system in a digital age? How do we meet regulatory requirements? Can we simplify the filing system, not filling system, the filing system? How do we ensure the exchange of knowledge among our employees? What do we need to reduce our costs? What option do we have to optimize maintenance? How do we sustainably ensure plant availability 24 hours, 7 days? These are really questions on your journey, and this is, I think, mandatory to ask these questions. And I don't know exactly which challenges do you have in Malaysia, but I think there are same challenges as I mentioned here. What I see also often is leakage reduction, non-revenue water, and you have also seen possibilities in the presentation of Bentley Systems, how we can visualize this kind of non-revenue water. Yes, and I got also the question, or I saw the question from colleagues from you, what are the benefits of digitalization? And global water intelligence in the nice brochure, Water Digital Future, they are saying we have direct benefits, but we have also indirect benefits. The direct benefits is also always reducing costs, like reducing labor costs, or improved energy efficiency and optimization, or reduced chemical use, or to have increased security of supply and reduced downtime, and leak reduction, non-revenue water. Yes, we have solutions like that. We can combine our automation control with leakage reduction software packages. And also the accurate billing is necessary to have your financials in place. But there are a lot of indirect benefits. And sometimes you have also to focus on the indirect benefits. Like, as Richard also mentioned, improved quality indication towards the public, how it looks like, or a clearer picture of the overall state of an entire water cycle, and improved compliance. I think this is also mandatory to have these indirect benefits of digitalization. Or continuous monitoring provide public health benefits. Real-time usage of data improves customer service and experiences, because you have also your customers, they have their experiences and their needs. And via digitalization, digital twin, you have really the possibility to improve customer services. And also increased environmental protection and comply with the regulations. You have also to increase the reliability and consistency across all the plants. As Richard said, if you have a digital twin of your city, of your system, of your pipes, of your distribution network, of your pumping stations, of your different wastewater treatment plants, then you have an increased reliability and consistency across all the plants, because you know about your assets. You know about all your assets and quality and maintenance stuff. And I think this is always important to have what are the benefits for digitalization in mind, direct benefits and indirect benefits. Leakage detection, yeah, it looks nice. Software is needed to detect leaks and to save water, and also to have the accurate billing on these systems. Coming to the next slide, and I think it looks a little bit different, but it has the same structure like this maturity check. So we have the computerization, connect and monitor, and as Richard also mentioned, we have now the level degree of number 3. What is happening? Most of our utilities here in Germany and in Europe, they are on the observe level. What is happening? Some of the utilities are going the next step. Why is it happening? They understand about the water cycle. They understand also the next step. What is likely to happen in stormwater if a stormwater management occurs? Be prepared. Is my system available? What is likely happening with simulation modeling? And as also we already heard, how can autonomous reaction be enabled? Self-optimization is the key of the Water 4.0 approach. And you have to think about in which level you are at the moment and where you would like to be in the next 5 or 10 years. It's a digital transformation. And this is also the lessons learned, what we have seen. But you have to start, and also as Richard mentioned, you have to start with this maturity check. And I think Mr. Oehlmann is keen also to support you in Malaysia. And based on this maturity check, we are saying with our standardized solution, with our standardized templates, with our standardized SCADA systems, you can go the next step of digitalization. And many of our utilities here have standardized on systems because they see the advantage, they see the benefits, the direct benefits and the indirect benefits on standardization. And they're going the next level of digitalization, the digital twin. We have heard a lot of digital twin at the moment, about the process digital twin and the hydraulic digital twin, which was presented by Richard and his team. And this merges the virtual and the real world. And the question was also, what does it mean? What does it mean in time? What does it mean in costs to have a digital twin on a wastewater treatment plant? It depends. It depends on the quality of data. And the next step is, if you have really this digital twin available, then you can think about a connected data environment, continuous optimization through analysis, artificial intelligence, simulation and modeling, and to optimize also the operations. But technology is not all. So we have a lot of information systems available, but we have also to think about the resources which are necessary to go this way. We have to think about organization and culture in the utilities. And you have also to ask the question, where do we stand in terms of digitalization? What digital development opportunities exist? Where do we want to go and what is useful for our company? These are major questions in this maturity model, and all the companies should answer these strategic questions. And this is also where we would like to go, and this is beneficial for us, but also beneficial to have a clear overview in the utilities. Where do I stand and where would I like to go? This is, let's say, the digital twin is also a journey. We need this horizontal integration. What we have also to think about from the field level to the IT level, we have to think about digital twin performance in the cloud, because artificial intelligence and cloud performance is necessary to have this digital twin approach to make it happen. And this vertical integration of OT and IT, I think this is mandatory to have these cybersecure systems also on board. This shows a little bit of the portfolio. What I'm talking about is from the field level via the automation level to this management and control level. All this all these integrated performance software packages are necessary to have really a smooth operation of your wastewater treatment plants, pumping stations, desalination plants, and also wastewater treatment plants. And in addition to that, yes, we apply our software packages like leak detection, and we have also a common development in the cloud level to create this digital twin with our experience in automation and control. And plant side, we have seen it is a common development between Bentley and Siemens to combine our strength in the digital twin technology. Okay, only a small recap. We are talking about this water cycle, and we have different solutions to have automation, digitalization available for all this kind of sub-segments, and including nice technologies on different necessary leak detection or reduce of non-revenue water. So coming to, let's say, nearly to the end, this picture is also, let's say, our ecosystem and also our vision of a digitized and networked water management system, including also in respect to the European Water and Wastewater Directive. So this is the overall picture in Europe, where we start with the physical water management system level on the wastewater side. The next level will be, let's say, this digital twin, including also the consumption, the weather data, the GIS information, and final stage is to have really the second level of business level digital services and networking, where all the different benefits are shown on the overall platform, like sewer control systems, like also the reporting system on the European water quality level. And I think this will be the vision of a digitized networked water management system, which means this is based on standardization and also digitalization, and coming to the end to a connected data environment with cyber-secure systems, with cyber-secure platforms on the field level. And I would like also to highlight a statement of Richard in a nice brochure here in Germany. The digital twin has the potential to become the digital lifecycle instrument of the planner, the operator, and the owner. They will help to increase the effectiveness, efficiency, and resilience of the management and operation of facilities and infrastructure. And this picture in mind, I will nicely have also a movie which is available on YouTube showing a wastewater treatment plant combining a little bit of all the technologies. Sorry that the sound is not working properly, but I think it also gives a good impression what we are talking about. This is a wastewater treatment plant in Switzerland. This is the operator of this wastewater treatment plant. They combine 3 wastewater treatment plants to 1 treatment plant in order to comply with European regulations. And Cody Plaza is responsible to operate this new wastewater treatment plant, combining also solar energy for energy consumption, but also the 3D modeling of the complete plant as a 3D model. And what I'm saying is the consultant, they have to do their job. They have to do nice and intelligent PIDs. Otherwise, you have only nice drawings, but without any content, which means you have to combine 3D models with automation and control from the planning phase to the execution phase, and then also to the operation phase, because the operation phase takes more than 30 years, and you have the possibility here to have really all the information available if you have a strong consultant with the good PID documentation, and this will help you, yeah, to have PIDs available with intelligent asset management performance behind that. And this is key also for the operations and the benefits out of the operation. And this is also a combination between simulation of the aeration and which reduce the energy consumption by roughly 20%. Combination of automation, simulation, and digitalization will save cost. This is quite clear and shown in this new wastewater treatment plant in Switzerland. Okay, coming to the end and to the questions, combining is standardization is key for the digitalization, the digital twin merge virtual and the real world. And then we can talk about a connected data environment, including cybersecure and cybersecure systems, including simulation and modeling. And I think this will be the Water 4.0 and also the lessons learned from our journey here in Europe, here in Germany. And as Richard said, we have to start now. We can help you. We are beside you. And also our colleagues locally are working on water, because water is the heart on sustainable development and crucial for agriculture, climate change, energy efficiency, environment security, urbanization. Society will benefit from digitalization as well as the industry. And finally, the health is important for us. We have a nice Siemens Water Expo. They will start on the 12th of May, giving also impressions about leakage control and IoT solution in United Kingdom, where big utilities are now doing a nice IO project with us. Thank you very much, and I'm keen to answer your questions.
Thank you very much, Mr. Simon, for a very nice presentation. I would like to open the floor for question and answer. Any questions from the floor?
Can I open the curtain, please?
Yes, Dato', sure.
Yeah. Thank you, Mr. Christian. I think it's a very good presentation, and you have depicted the holistic approach on the Water 4.0, looking to the whole cycle of water. Well, my short question is, I saw that slide that shows on the 3 layers of the source and up to the operator side. I'm just wondering whether is that all, or you have covered the recycle part that touch into the circular economy. Why I ask this question, because one of the intention of the water sector transformation for Malaysian chapter is to look at converting the water sector from cost center to become profit center. So we're looking at helping the growth of our GDP in Malaysia. And as that your system that you showed just now covers everything right up to the water cycle for waste to wealth.
You know, I answer this question in this respect. At the moment, if you have to talk about a profit center, this is also a journey. Finally, it's not implemented here in Germany because it will be a cost center supported by the government of Germany. All the participants, all the consumer have to pay their fees, but sometimes these fees have to be leveled, and there will be no profit out of these activities. We have really challenges to overcome this financial thing, because, as I mentioned, water is a human right, and the municipalities are responsible to supply water in the right quality, and they have also to do the disposal of the wastewater towards the rivers. And this is the big challenge, that you have to pay for it, yeah, and to pay it's sometimes difficult to convince our consumers to pay for water because it's a human right. So it's a challenge. But if you have a clear understanding about your policy, I think this is mandatory to overcome these hurdles and then to have not a cost center, but a profit center, which bring also additional money for investments in new technologies. I think it's positive to see that the profit center is in discussion in Malaysia.
Thank you. Thank you very much. Yep.
Any other questions from the floor?
If there's none, I would like to pose another question on the Germany experience on this Water 4.0. I did put up my question on the chat, but anyway, I just want to ask from your experience of the transformation, how long it take to get Germany to where you are now?
It's also a good question. So I'm also on thinking about when we started this journey. I think we started this journey with the Water 4.0 brochure at the IFA show in 2016, where we brought up this Water 4.0 brochure towards the policy to the government, and they saw what is necessary, because water is not always on the top level in the governmental structure, because in Germany at the moment we do not have such problems like in other countries. But we started this journey, I think, 2016. The companies, utilities, as I've shown also in the movie, they started the journey maybe 10 years ago, because they have seen different SCADA systems in their plants. They decided this is not the way to go forward. So this standardization process started, I think, 10 years ago. Yeah, and now, but the speed increased tremendously, because Water 4.0 is driving the digitalization. Also, our COVID-19 pandemic is driving this digitalization. And now we are talking with utilities about not standardization. We are talking about digital twin. We are talking about how we can bring all this dark data which are available into a digital twin, yeah, to use this data which are available. And we are talking about digitalization and to come from the level 3 to the next level of 4. What I see is we need these pilot projects. We need this, we convince municipalities to do something, to start something, to start a discussion. And I think over the next 3 or 5 years, we see a lot of digitalization, a lot of digital twin use cases. And at the end of the day, the speed is going on, and digitalization, you cannot stop it. And the next step, as Richard also showed, it's a conservative sector, but the speed is in the governmental side. And for this reason, we started 10 years ago. Now we are on maturity check number 3. We will follow number 4 in the next, let's say, 2-3 years. Maybe on the next IFA show next year, we will have already a nice use case for digital twin concept as a huge utility. But they start now small with the pilot plant. They would like to extend on 5 or 10 wastewater treatment plants. They will also start a big pumping station for digital twin, and also to enable the automation and control with virtual reality. It will start as a huge impact next year on the IFA show. But it's a journey. It's a journey. And as I mentioned, we have 6,500 utilities for water, 6,400 for wastewater. They need pilot projects. They need, they have to get shiny eyes. What I'm saying is they have to get shiny eyes and see the possibilities of digitalization.
Thank you, Mr. Christian.
Thank you, Mr. Zem. Any other questions from the floor, ladies and gentlemen? Certainly, it has been a very nice topic and sharing from Mr. Christian Zemmer, as well as our previous two speakers. And I would like to thank Mr. Christian Zemmer for a very nice video. And we hope to get the links from your good self later on, and we shall share with our participants today. Therefore, I think we shall end the session shortly. May I invite everybody before we go to please kindly switch on your video for a group photo. Just stop sharing. Okay. We have over 50 participants from 3 o'clock just now, but going down to 37 now, and we have a couple on YouTube and Facebook as well. So thank you very much for staying in until the end of the session. I will begin the photo session now with a screenshot. So please give me your best smile for the morning and also for the evening here in Malaysia. Okay, so after 3, 1, 2, 3. Okay, and another one, please. Okay, 1, 2, 3. I'll do another one for the next page as well. Just 1 second. And then 1, 2, 3. Yep, can do that. Okay, so thank you so much for today, Dr. Vesner, Mr. Martins, and Mr. Zeimer, all of our speakers from our German water partnership. And I can see that some of our colleagues are also joining today. Thank you to Dr. Salma Zakaria, Chair of Project Management Committee from Academy Science Malaysia. We have Datuk Pateh also. Thank you, Datuk, for joining us. Thank you, everyone from all of us here at Academy Science Malaysia, the Malaysian Water Association, and also German Water Partnership. I'll be seeing you again tomorrow for the final day of webinar IR 4.0 for water subsectors. So see you tomorrow. Have a nice day ahead in German and also here in Malaysia. Thank you so much.
Goodbye. Thank you.
Thank you. Bye.
Thank you. Thank you, Tan Sri. Thank you, Encik Azhar. Thank you so much. Thank you, Elaine.